Right, so let's take a look at section 4.3. Let's look at this one. So remember, to use the law of sines, you got to have a row that's complete. We have to have a row that's complete. Okay. Do we have a row in that table that has everything in it? No. No. Do we have a way we could easily find something to make it complete?
You can. Oh, maybe not.
Well, if it was a right triangle, we could use Pythagorean Theorem. But we can't use that. Do we have a way to figure out an angle? Like, can we add 2 together and subtract from 180? No, because we're missing 2. We don't have 2. So this type of problem you can't solve with law of sines. Okay? If you try, okay, pick 2 rows, and there can only be one variable. Well, if you pick the first 2 rows, that's a problem. You're missing 2 things. If you pick the last 2 rows, you're still missing 2 things. If you pick the first row and the last row, you're still missing 2 things. You can only be missing 1. Right? So this is an example of side angle side. Okay? If you were to sketch this out, that's what it would look like. Side angle side. It's also used for one other type of triangle. Anybody think of one more way you can arrange these letters?
Angle, side, angle.
So we've got angle, side, angle. That's a good one, but that is under law of sines. Side, angle, side. That's the one we just did.
Side, side, angle.
Side, side, angle? That's law of sines.
Side, angle, angle.
Side, angle, angle. That's law of sines.
Well,
3 sides.
how? There's no
3
way to
sides.
rearrange these words.
Side, side, side.
You can only have 2 sides.
Well, side, side, side is the third type. Right? If they give you all the sides.
Oh, right.
Yeah.
I thought you were saying, see.
I'm like out of those.
I thought you were saying out of the SAS that we already had. So I was absolutely.
Oh, just yeah. Okay.
I wanted to use a good word.
So there's side, angle, side. Okay. You know, 2 sides and an angle, and the angle you know is between the 2 sides, you know. And side, side, side. Okay, there's another way we could arrange the letters. That's angle, angle, angle. But that problem wouldn't be solvable. All right. That'd be like if I said to you, I have an equilateral triangle. Okay, you know all the angles are 60. And I said, how big is each side? Well, if it's an equilateral triangle, all the sides could be 2, 2, 2. They could be 7, 7, 7. You don't know. All right. So knowing all the angles won't help. So you'll never have one like that. Okay, for the law of cosines, the proof to go through it, it's not hard, but it involves some trig identities we haven't done. So I'm going to give it to you and see if you can kind of recognize what it looks like, okay, or what it starts off like. Okay, anybody recognize what that kind of looks like? Yeah, it kind of starts off looking like the Pythagorean Theorem. And in fact, if you were going to prove the law of cosines, that's the formula you use to do it, the Pythagorean Theorem. But we can't just use the Pythagorean Theorem. There's an adjustment. Okay? There's something we have to subtract because the angle's not going to be 90. This part I'm just going to give you. You don't have to prove why this is what you subtract. Right, so this is what we subtract. So it's c squared equals a squared plus b squared minus 2ab cosine gamma. Okay, and what you want to try to remember here is the general pattern. One side squared equals the sum of the other 2 squared minus twice the other 2 that you just used right before it, a and b. It's always cosine. And the angle you put at the end is the one that's across from the letter you would start with. Right, so we can write it 3 different ways. We can start it with c squared, b squared, or a squared. And it just moves the letters around. But they all have the same format. Does everyone have this one written down?
So if you were looking for b squared, you would just switch b and c to?
Yep, let's do that. All right, so now let's look at the one that starts out b squared. Okay, anyone think based on the pattern above they could figure out what two letters would be here? A, and what would you do with each one of them? Add them? Whatever.
And square them.
And square them. So it's b squared equals a squared plus c squared minus 2
Easy.
AC, yep, the letters you just used, cosine
Jada.
beta, the angle that's across from the side you started with. Okay, that's not a different formula, it's just a way of rewriting the top one. Okay, they're both law of cosines. And what do you think the last one is going to start out with? Yeah, it's going to start out with a squared. Okay, Mariah, what do you think is going to come after a squared? A squared equals,
B squared
yeah,
plus C squared.
good. B squared plus c squared. Okay, one side squared equals the sum of the other two squared. Minus 2. Holly, what letters are going to come next?
BC.
Yep, BC. And then cosine of the angle that's across from A. Chelsea, what angle would that be?
Alpha.
Yeah, alpha. Right, so 3 different versions of the law of cosines. Which one do you use? Well, depends on what you want to find. If you have a problem where you know alpha to start with, you probably want to use the last version. If you have a problem where you're given beta to start with, I'd use the second one. Okay. Likewise, if you were given gamma, I'd start with the top one. Okay. Sometimes you have to do law of cosines problems in a certain order, sometimes you don't. Okay. I'll show you when you have to do it in a certain order and when you don't. All right. So let's go back. This is the first problem we had up right at the beginning of class. Okay, for law of cosines, I won't be giving you any problems that have no solution or more than one solution. They all just have one solution. All right, so first thing we'd have to do is make sure we understand why this is law of cosines and not law of sines. Okay. Anyone think they can tell me why this is a law of cosines? You can do it by looking at the table, or you can do it a different way, which we talked about earlier. Holly?
When you look at the table, there's nothing across from each other.
Right,
No, like,
yeah.
whole line.
Right, you don't have a whole row. Okay, if you don't have a row that's complete, and you have no way of finding anything to make a complete row, that's law of cosines. Or, if you wanted to just do the sketch, you're looking for one of two things. If it's law of cosines, it could be, what's one type?
SAS.
Yeah, could be side angle side, or it could be one other type. Side, side, side. If it's side, 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 I don't think you need to make a sketch. It's pretty easy. If you're given A, you're given B, you're given C. That's side, side, side. All right. So if we put B, put beta across from it. A, put alpha across from it. C, put gamma across. Okay, we confirmed it. It is side angle side. When you have a side angle side problem, you have to do it in a certain order. Okay, there's something you have to find first. Anyone have a guess what we're going to have to find first? Or if you're not sure what you have to find first, maybe think about which version of the law of cosines you're going to have to use. Let's call this one 1, 2, 3.
1.
You're going to have to use 1. Why?
Because we're getting gamma and no other angles.
Right, we're given gamma. Okay? If you look at each version of the law of cosines, they all have A, B, and C in them. Okay? Every version has A, B, and C. We're already missing C. We can't be missing anything else. Okay? If you try to plug into the bottom one, you're going to be missing C, and you don't know beta. Okay? That's a problem. If you try to plug into number 3, you're missing C, and you're missing alpha. Okay? If you plug into the top one, the only thing you're going to be missing is C. Everything else after C, A, B, gamma, you know it. So we'll just fill it in and see what we get. All right, so we have C squared equals A squared plus B squared minus 2 times A is also 2 times B is 3 times cosine of 60. Okay, now the biggest mistake I usually see is in order of operations. People forget about PEMDAS. All right, so we'll just go through carefully. First thing you want to do is your exponents. Charles, what's 2 squared?
4.
3 squared?
9.
9. Now we can do our multiplication. 2 times 2 times 3. 2 times 2 is 4 times 3 is 12. Cosine 60. Okay, what would I do next here? Okay, we could do the addition, and it wouldn't mess anything else up. But if you follow PEMDAS, what do you have to do first? Yep.
12 cosine 60.
Right, we should do the multiplication first. What I want to avoid is don't accidentally do 9 minus 12. You can't do that. Any more than if you had 9 minus 12 times 5. If you're multiplying 12 by a number, you've got to do that before the subtraction. Okay? But yes, you could do the addition because that's separate and it won't affect anything else. Okay, so I'll do the 4 plus 9. And I'm going to do my multiplication, 12 cosine 60. Okay, again, make sure you're in degrees. Nothing will be in radians today, or all week. Okay, so 12 cosine 60 comes out to 6. Let's say you're not comfortable doing it all at once. You could do it in 2 steps. Get the cosine of 60 first. It's 0.5. Okay, maybe that's a little easier. Okay, or a half. And we do half of 12. We get 6. 13 minus 6 gives me 7. And I'm close to what I want. I want C. So what do I have to do on each side? Yeah,
Square, find the square root.
yeah, exactly. Just take the square root, and we'll round it off. Okay, so take the square root of, again, second, square root of 7. It's about 2.646. And that's C.
Wouldn't you rather use it a whole number than a decimal?
We're going to have to plug it in to use it in the next part, Jimmy. So if we just have it as a decimal, that's okay. Yeah. If you round to 3 decimal places, that'll be plenty accurate for what we're going to do. What probably wouldn't be as accurate if you round this to 2.6. That's not enough decimals. Okay, but if you do 3, I'm fine with that. Okay. Any question on how we got C? Let's just write it on the diagram. Now you could treat this triangle as a different type. You know all the sides now. You could treat it as side, side, side. If we thought about it that way, what law would we use for side, side, side?
Law of cosines.
We'd use law of cosines again. Well, you can think about it one other way. Side, side, angle. What law would that one fall under? Yeah, if you think about it as 2 sides and an angle, it's law of sines. But what don't we like about this case with law of sines?
Give me a two answer.
Yeah, this is the case where we got to deal with, well, is there two answers? Is there one answer? No answer? All that stuff. So we're going to do law of cosines again. Law of cosines will automatically give us the right answer without having to think about all this other stuff. All right. Now we have a choice. You can find alpha or you can find beta. Okay, look at the formulas. The formulas for alpha and beta all have A, B's, and C's. And we have A, B, and C. So we can do any one we want. All right, so Chris, which one do you want to do? You want to do alpha or beta? Alpha, okay.
Be sure about something for once you
All right, so alpha, we're going to solve for that one, you're going to use version 3. Okay, a squared equals b squared plus c squared. Okay, as I go through it, I'm going to square some of the things in my head so we don't have to write as many steps. If you're comfortable and you like writing every single step out, that's great. You can do that on the test. But just to save a little space, let's try to do some of it as we go. Okay, so it's a squared equals b squared plus c squared. Right, so a squared equals b squared plus c squared. I already know from the last problem. I did some work, okay, and c squared was the second to last step. So it's a squared, b squared, c squared minus 2 times b times c. So 2 times 3 times c is 2.646. Okay, you know what? Since we have a decimal, we'll just do it like that so we don't get confused. Okay, and the last thing I have to multiply is by cosine of what? Alpha. Yeah. Cosine alpha. Okay. Any question on setting that up? All right, so let's go through. 9 plus 7, that's okay to do separate even though it's addition. Just don't do 7 minus 2. Okay. We're going to do all that multiplication together. So 9 plus 7 gives you 16. 2 times 3 is 6. And now we need 6 times 2.646. So 15.876. Okay, and most of the time, this is where people make a mistake. What would I do next there? If you get stuck, I'll give you something from Algebra 1 that looks very similar to that, and then I think you'll know exactly what to do or not to do.
15.876 times cosine alpha.
All right, if we knew alpha, that's what we'd want to do. If we had a number for it. But we don't have a number for it, so there's nothing I can really do with the 15 times the cosine.
Can you inverse it with that?
We are going to have to use inverse. It's a good idea. It's just not going to come up to the very last step. But that is going to come up.
Subtract 16?
Yes, subtract 16. Okay. The mistake a lot of people make is they do 16, take away 15.876. You can't do that. Your equation is basically something like this. It's a number equals another number minus, and then it's a number times something you don't know. Okay. Are 16 and 15x like terms? No. If you multiply a number by something you don't know, you can't subtract it. They're not like terms. So as JC just said, move 16 to the other side. And JC, what does that give me? What's
Negative 4.
negative 12? Good. Cosine alpha.
Now,
I'll put parentheses just to maybe remember this is multiplication. Yeah. Okay. think of this problem if you were solving something like this in algebra. Now you have a number on one side equals a number times something you don't know. Divide by the number that's next to your letter. Okay? On each side.
Fractions.
Yeah, you're not going to have to do it out though. You just use your calculator. All right, so yeah, you're just going to use your calculator. What do I divide each side by?
Negative 15.876.
Perfect. And same thing here. In fact, I'm not even going to do that out in the calculator because I don't really care what 12 divided by 15.876 comes out to. I just care what alpha is.
We gotta do inverse cosine.
Yeah. So when you divide, the 15 cancels. Negative divided by negative is positive. And on the left-hand side, negative divided by negative is positive. Okay, and what did you say, JC, to get that by itself?
Inverse cosine.
Yeah. Okay, that's equal to cosine alpha. So if you use inverse cosine, it's going to cancel that. And alpha is, now we type it in, the inverse cosine of 12 over 15.876. Okay, so if you can solve an equation from Algebra 1, that's all that the law of cosines is. Just make sure you do the proper rules for solving an equation. Right, this, I think, is straightforward. You can take the whole thing in at once. 12 divided by 15.876. Just make sure you're in degrees. Okay, so it's about 41.900 if we're rounding to 3 decimal places. Any question on alpha? Because now our work is basically done. All right, so now we have 2 out of 3 of the angles. What could I do to get the third angle now? Yeah, just add these together and subtract from 180. All right, so if we add that, we get, that's 101.9 minus, so beta is 78.1. And if we're going to 3 decimal places, 0.00. Okay, let's check and make sure that the smallest side is with smallest angle. Yep, biggest side should be with the biggest angle. That looks good. And if you add any 2 sides together, it should be bigger than the third one. If anything I said doesn't work, then something's definitely wrong. Okay, so that's a law of cosines problem. Doesn't get any more or less difficult than that every time. Any question on any part of that? Yeah?
Add some water, please.
Yeah, go ahead.
No.
All right. So that was a side angle side. Let's look at this one. Well, it's going to be the same law. I don't think we need a diagram to figure out the type of triangle this time. What? It's side, side, side. They've given you all the sides. Again, the reason why you can't use law of cosines, yeah, you don't have any of the angles. No matter which 2 rows you pick, you're always going to have 2 variables. Pick the top 2 rows, the bottom 2 rows, or the first and the last row. Now,
So you can use 1, 2, or 3.
you can use 1, 2, or 3. Okay, with side, 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 there is no, you don't have to use a certain version to start. Okay? You have to do it twice. Use law of cosines to find 2 angles, then subtract from 180. Okay, so let's use a version we haven't used yet. Okay, we already used alpha. Let's find beta. Okay, what we'll do is let's copy over what the law is right here, so then we can remember as we're putting it in.
B squared.
Yeah, so to find beta, it's b squared
E equals A squared plus C squared minus parentheses
Yep.
2 AC
2AC. Good.
cosine beta.
Cosine beta. Okay. Fill in A, B, and C. What's going to be nice about this is A, B, and C, there's no decimals. So most of this we'll be able to do in our head. Okay, so B squared is 9. Okay, A squared is 16. And then C squared is 36. 2 times A times C. Okay, what's 2 times A? And then 8 times 6. 48. So by doing the squareds in our head, doing the product in our head, we eliminated having to rewrite this a lot of extra times. Okay, about Mariah, what would I do next?
Add 16 and 36.
Good. I'm going to add 16 and 36, and that'll give me how much? 52. Good. Okay, how about Carlos? What's my next step?
Minus 52 and plus 52.
You want to add 52 to both sides? Well, if you add 52 to 52, do you get 0? If you do 52? Yeah, subtract it. Whatever you do, you want to get rid of it. You want to get a 0 there. Now, if you do 52 minus 52, you get 0. All right, so we get 9 minus 52. It's negative 43. And we're almost done. We just have 2 steps left. Okay, Rosa, what would I do next?
You would divide both sides by 48 cosine beta, negative 48 cosine beta?
Well, tell me, what would you do if it was this? And I asked you to solve for x. What would you get x by itself there? Remember, this is negative 48 times x.
You divide them?
Yep, you divide, but what would you divide by?
You divide by negative 48?
Yeah, just negative 48. Okay, so you're just dividing by the number. Okay, nothing else, just the number. Good. So 48 divided by 48 comes out to 1. Negative over negative is positive. And then those negatives also cancel out. So, yeah. And now I'm at my last step. Cassandra, what can I do to get rid of cosine? Yep, I'm going to do inverse. Yeah, inverse. So inverse cosine. Inverse cosine. Now we take that in, and we'll have beta. Okay, some people like doing the law of cosines better than law of sines because there's no proportions. There's none of that cross multiplying. Some people think the cross multiplying is easier. It's really just a lot of arithmetic. It's all in Algebra 1. All right, so beta is 26.384. Now, did I have to do beta? Yeah, we chose to do beta. Okay, we didn't have to do that one. And we have a choice again. We're either going to do alpha or gamma. Yeah. And my advice, especially on the test, would be find alpha, add it to the one you just found, subtract from 180. If you have extra time, you could do the law of cosines 3 times and find all 3 angles separately. It's going to take longer to do it that way, but it's also a good check to make sure you did it right. Okay. In the notes, I'm not going to do it the long way. I'll do law of cosines one more time, and then that's it. Subtract from 180 after that. All right. So for our last angle, we can find alpha or gamma. How about Jimmy? Which one do you want to try to find? Top one? Okay, alpha. All right. So that's going to be a squared equals b squared plus c squared. 2bc cosine alpha. Again, fill in ABC and see what we get. All right, so I don't have to keep scrolling up and down. You guys get it right on your paper. What was A? Well, Zach, what was A? I just don't want, so I don't have to keep going like this. Then, yeah. 4. So we square it and get 16. Go ahead, what's B?
I don't have a problem there.
No problem. Does anyone have that? 3. So we'll square it and get 9. How about C? 6. 36. Minus 2 times 3 times 6. Cosine alpha. Okay, it's okay to add 9 and 36 because that's not going to affect doing 2 times 3 times 6. Just don't do 36 minus 2. Can't do that. So 2 times 3 is 6, then times 6 is 36. Okay, Brooke, what would I do next? What would I do next?
Subtract. Maybe, I don't know.
Yep, subtract. What could you subtract? Yeah. You know what you're doing. Right? Subtract 45 from both sides. Okay. Now we've got 16 minus 45. We've got 2 steps left. Let's see if we do both in the same step. Okay. What's the first thing I do to get alpha by itself?
Divide negative 36 on both sides.
Divide by negative 36. That's also going to cancel. And what's my last step?
Inverse cosine.
Inverse cosine. So let's just write it in. Inverse cosine. If you want to cancel the 36, then rewrite it, then cancel the cosine, then rewrite it again. You could do it that way. Okay. But we need the inverse cosine of 29 over 36.
That takes away the negative, right?
Yep, it takes away the negatives because we had negative over negative, which is positive. Yep. That happens a lot of times in these problems. You have 2 negatives that cancel out. Not always, but sometimes. Okay, 36.336. And that's alpha. Okay, last step, add them up and subtract from 180. Or just subtract them individually from 180.
You got 36.36, you just divide 29 divided by 6, correct?
Yep, I typed in inverse cosine.
Oh, okay.
Yep, inverse cosine of 29 over 36. Okay, so subtract first angle, subtract your second angle. And if we did that right, it should be 117.28. Okay, now on the test, if you get an answer like 117.29, 0.3, 0.31, because of your rounding, that's okay. But if you get an answer like 118, that's a little far off. Okay, so if you're within 2 3/10, that's okay. Like 26.5, I would accept that. 27.5, yeah, that's a little too far off. Yeah.
So instead of, like after you find one whole row, instead of doing the law of cosine again, can you just do law of sines? It's easier.
Well, you could do law of sines. You just got to be careful. If it's that one that's 2 solutions, then you got to go through all that work. All right. My advice to you would be to use law of cosines twice. Usually when people use law of sines like halfway through, something gets messed up. So, but it's up to you if you want to try it that way. All right. So there's an example of side, side, side. All right. All right, so yeah, our last one is our frog. We'll talk about the frog. The last one will be a word problem, okay, which basically means if you can somehow just make a diagram and get a triangle, you're good to go. Okay. All right, so in this problem, a surveyor is trying to find the distance between 2 points. Or 2 houses. We'll call them house A and house B. Those are our 2 points. And when the surveyor measures an angle to one house and then the other house, the angle between the houses comes out to 70 degrees. Okay, I'm going to help you out with the diagram and show you where that is. Okay, the surveyor is then able to walk off the distance to each house. Okay. Measures the distance to one house, it's 50 feet. Measures the distance to the other house, it's 70 feet. So maybe you could think there's like a canyon or something between the houses, right? Maybe it's like 200 feet across. So you can't just do a tape measure straight across it, but he can walk to the house on one side, can walk to the other side, and then he'll get the distance across. So these are the 3 things that are important. We've got an angle to the houses, and then the distance to each one. Okay, so how far apart are the houses? Now, if you wanted to be, a little bit more creative about why the surveyor couldn't just walk between the houses, maybe it's not a canyon. It could be poisonous tree frogs. Okay? So, if there's poisonous tree frogs in between, he can't walk between the 2 houses, but he can use trig, so he doesn't die from a poisonous tree frog. Okay, so this is going to represent our surveyor. It's actually a picture of a World War II trench soldier, but that's all I could find quickly. So here's our surveyor. All right. Basically, our 2 houses, and then where the surveyor's or soldier is standing, there's our 3rd point. Let's make your triangle. There's your triangle. It says in the problem, angle ACB. ACB is 70. Okay. The distance to house A is 50 feet. Distance to house B, 70 feet. Okay, what kind of triangle is that?
Side angle side.
Yeah, it's a side angle side. Which is what law?
Sides. Because it's basically
Side angle side?
cosine.
Yeah, it's law of cosines. Yeah. And all you want to find is this. Okay. This is where I would just try to think of the law of cosines in general. Don't try to figure out what side is A and B and C, because they're using A and B to represent houses, which are like the vertices, not the sides. So let's just see if we can set up the formula. It's going to start out x squared. What would be the next 2 things in the formula?
Y squared plus z squared.
Well, everything else has to be a number now,
15,
because that can be our only letter. So now we're going to just use all these numbers.
So 50 squared.
50 squared? Good. 1 side squared equals the sum of the other 2 squared minus, what would come next?
2 times 50 times 70.
Good. 2 times the sides you just used right before. 50 times 70 times the cosine of what angle?
70.
Yeah. The cosine of the angle that's across from the side you started with. And that's it. That's our equation. So we just use our calculator and find x. Okay, I'll leave that part for you. All right, so the homework tonight, okay, just six questions to try. None of them have no solution. If you get one with no solution, shouldn't be no solution. So 274, 9, 11, 13, 17, 25, 27. And don't forget, I'll check the homework that was due today. I'll check that tomorrow. So if you didn't do it, you get an extra day.
All right.